What is the value of I to the power of I, where I is the square root of -1, an example of an imaginary number? Is I to the power of I real, which means it's not imaginary, or is it imaginary, or is it not defined? We're going to find out. Now, a complex number, for example, 2 plus 3i, consists of a real part and an imaginary part. And when we have a complex number in this form, something plus something I, that's known as Cartesian form. But we can write complex numbers in other forms as well. This is known as an Argand diagram. It's just a way to plot complex numbers. So for example, if we had 2 plus 3i, we're 2 on the real axis and we're 3 on the imaginary axis. So we could plot 2 plus 3i on an Argand diagram like this. There's another form of complex numbers called modulus argument form. And the way we convert it to that is this. The angle from the positive real axis is known as the argument of the complex number, and the distance of this complex number from the origin is known as the modulus. And we could just use basic trigonometry to work out what the theta is, the argument, and we could just use Pythagoras theorem to work out what the modulus is, the r is. But once we've worked out that r and theta, we can write the complex number in this form, r brackets cos theta plus I sine theta. There's actually a third form we can write complex numbers in, and it's known as exponential form. And that form is r e to the I theta, like that. Now let's consider how I itself can be written in modulus argument form, and hence exponential form. If we draw I on an Argand diagram, I is just going to be here because it's 1 on the imaginary axis. So the angle from the positive real axis is going to be 90 degrees. But when we're working with complex numbers, we use radians, so it's going to be pi over 2 radians. And we can see the distance from the origin is just 1. So that means we can write I as 1, because that's the r, brackets cos of theta, so cos of pi over 2, plus I sine pi over 2. But we could also write an exponential form. That would be 1 e to the power of I times pi over 2, like that. So that's I in exponential form. Now we want to work out the value of I to the power of I. So that means we could write e to the I pi over 2 to the power of I. And then using laws of indices, because we've got a power raised to a power, we just multiply those indices together. So we're going to have e to the power of pi over 2 times by I squared. But the thing is, because I is defined to be the square root of -1, then I squared is just going to be -1. So we get e to the power of minus pi over 2, and that is the value of I to the power of I. Now there's no I in this expression, so this is actually a real number. E is just approximately 2.71, pi is approximately 3.14, so this is just going to be some bog standard decimal, and therefore I to the power of I is real.